Hello team, today's challenge is hidden key, where we are given the challenge of going through all 250 existing challenges, including this one today, and generating a key that we can use to decrypt these strings down here, okay? So we go through all 250. If we can divide by 25 for that day's challenge, then we use the first letter of the title. And we do say the first letter, not the first number. So some interesting stuff there. And then we convert that letter to a value, okay? And we use that to shift whatever this letter is, right? Going around in a circle, in a cycle until it's done, okay? This isn't the first video for this. We actually covered how to get this key in the previous video. So if you haven't watched that, very cool, very interesting stuff. We actually went outside of FreeCodeCamp and went into the terminal to get that done using a little bit of curl and a little bit of something called JQ, right? So that we could access the information from that using this URL that already exists, right? So yeah, we did that and we got this response down here, which we can totally start using, okay? So the first bit is to take this, I'm going to cut it away and put it down here, okay? I'm going to set it as key, making it an argument so that if we decide to change the key later on, we absolutely can, okay? It means that the message has to be similarly ready to be decoded. Otherwise, we're just going to get junk. But if we had an encoder that used a different key, then we could pass in that key to the decoder and do the work, okay? Now, as part of this, I'm going to use something called TextEncoder, okay? Just like this. We need to use the new keyword for this, capital T, TextEncoder. Excellent, okay? TextEncoder might be new to you. If you've ever used something like string.charcode at, which I'm pretty sure we have in previous videos, this does all that work, but in one step. So the response back when we use TextEncoder.encode down here will be an array of UTF, of the numbers that relate to UTF characters, okay? If we went a.charcode at 0, we would get 65. If we went TextEncoder.encode A, we would get an array with one item, the 65, okay? So this is just a little bit faster than having to create a loop and do stuff. And we put it outside of the function because that way we can use it a couple times, which we absolutely will, okay? So we have that key, okay? We're going to get in here and we're going to do stuff. The first is going to be UTF start. Now I'm setting this as 64. 64 is whatever character is before the capital A, okay? When we decode that, I just hinted at it. The capital A is UTF, the UTF number for that is 65, okay? UTF-8, 65. So we're going to subtract 64 from all these different values to get different letters or different numbers that we can do math on, right? Shifting things back and forth and doing that stuff just through the alphabet, okay? So I apparently spelled something wrong, fixing that, but hopefully that makes sense. It is a magic number, but not so much when we realize how it relates to everything else, okay? We didn't just pull that number out of our butts. We actually used a logical thing here, okay? Now, we get our key values, okay? And this will be the first time that we use that text encoder. So text encoder, just like this, we go dot encode, and we toss in key, okay? Again, this is going to return an array. It's actually a special kind of array. It's called, I think, UTF-8 array or something like that. But we can still do stuff on this. Like as an example, down here, we can map, okay? Which means that we can take all those elements and funnel them to elements minus UTF start. Doing it right, start, just like this. And that way the values of these are their position inside of the alphabet and not just inside of UTF-8, okay? So even though technically what's returned from here is something that is array-like, it still supports a lot of the array methods. I think it supports all of them actually, but don't quote me on that, just in case you try it and you try it with something else and it doesn't work, right? It can happen. But now we have an array of these values, these keys, that are numbers, right? And we can use those numbers to slide the string, the message characters, backwards to their correct position, okay? Which means that down here, way down here, we set up our characters, okay? Now we are operating on some strings. And one of the things that I found, the reason that I'm doing this is because the spaces, okay? So do this part first. We're going to come back to that in a second. But the spaces, you would think that the spaces, whatever that index is, relates to whatever the thing is. But it doesn't, okay? The way that they've set this up is kind of tricky, okay? Let's imagine that this here, right, the encrypted version of congrats, let's imagine that this was our key, okay? So we pass that in, all is good in the world, and we start decrypting, right? And we have this one-to-one relationship all the way through where it's the first 6 characters, which is this, right? And you would assume that that X relates to that space, but it doesn't. Okay, and if you try to do one-to-one with the indexes, your first word will be right. Every other word will be wrong. And the reason for that is that X doesn't relate to the space, it relates to the next available character, which is frustrating. When I saw that, I was like, what is that? Right? That doesn't make a lot of sense. We could try to collapse the spaces and then put them back later or something like that. But I think the easiest way is just to split on any character, but keep that space with the next available character, okay? So we're going to have the Y by itself, the A, the L, the L, the U, the T, and then we're going to have an element that has space P, okay? And based on that, we'll be able to pull it apart a little bit, operate on the P itself, and then put it back together, and everything will line up, okay? Again, a little bit of confusion on that, but hopefully it makes sense by the end, okay? Now, split, we need a regular expression. It's going to be global, brilliant. And what we're doing is we are finding something behind. So this is a look behind, okay? And something out in front. This is a look ahead, and they're both positive. So a positive look behind, a positive look ahead. What goes in here? Well, it's going to be any sort of word character, okay? Which also includes numbers, but, you know, small things, okay? If you're worried about that, you can set this to A to Z, capitalized, because we're only working on capital letters today, okay? But I'm just going to leave it as /W to save myself some time, okay? Same thing over here. We want that /W again, but we also want a space. Okay, so /S for any sort of white space. And notice that we don't have any plus signs or anything on here, right? It's just one character and one character, right? It's either 2 letters side by side or a letter and a space side by side. The space always has to come second, okay? We're always splitting between that. And what'll happen is it will split between each and every letter, unless there's a space. Then it will skip, or it will include that space inside of that match. Okay. Hopefully that makes sense, because that took me a while to figure out, actually. So this gets the job done. Again, if we had a space in here, it would break this apart. It would be like comma and comma, 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 and then it would see that the space is in there, so it jumps to the next one where it's a letter, comma, 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 right? So that's the shape that we're getting from here, but not from our key, from our message, okay? Backing this out, getting rid of that space, moving on, okay? Now we get into the meat of it. So we're going to use those characters and we are going to operate on them, okay? So setting up a new variable, let's call this new message. In fact, let's call it new message codes because it's going to be the numbers. And we will translate those numbers back into an actual string pretty quick here, okay? That equals those characters. And from there we do flatMap, okay? The nice thing about flatMap versus just regular map is that we can send it an array and it will try to flatten that automatically into our final array output, which is exactly what we want. You'll see why in a second here, okay? So on that, we get a few things. One is the element and the index, okay? Remember that we have a magic space in there. So because of how we split it, this is going to line up one-to-one with our key, okay? Or we're going to cycle around. You'll see that in a second too, okay? So those should actually be in their own brackets so that we can complete the callback. Brilliant, okay? Now what goes in here? Well, we have to get the value of the element. So right here, we have our values. We go TextEncoder, just like we did above, encode L. Oh, I did that wrong. Let's jump over here. That should be a dot and then encode L, okay? And that's going to give us an array, which is usually one thing, but maybe two, okay? So right here, we're going to dig into that. And what we do is we get the letter value, okay, singular, which is values.at -1 minus UTF start, okay? That's a lot. So again, we get an array which will usually have one item, but could have two. And the first, if it does have two, the first will always be a space, okay? Always. Unless, of course, they've screwed up the message or the key or something like that. This should always be either one character, which is a letter, or two characters, which is a space and a letter, okay? Do we need more tests in here? Absolutely. But there's so much going on here that I'm trying not to focus on that part and just trying to solve for the challenge, okay? So letter value, that is our value. We're always getting the last item. That's what at -1 means, okay? And we are resetting it to be a letter inside of A to Z, okay? Otherwise, it will be something huge like 67, whatever that is, okay? We don't want that right now, so we're trying to do a thing. Now, down here, we want our key index, okay? Our key index is whatever this is going to be, right? We need to go here, but we also need to be able to loop around, right? So here we go. Key index is going to be whatever that index is, modulo key.length, okay? And what this ensures is that if our index is way bigger than whatever this key string is, okay, it's going to loop around to the beginning every single time, okay? That's just going to save us so much trouble. We don't have to do any sort of conditionals there. It just loops around, okay? If we get the first one, brilliant, it still works out. If we get something that is way over here, it will loop itself back until it's inside of this string, okay? So key index, and then what do we have? Key value, okay? So key value, and that is going to be key values. Oh, key values dot, no, not dot, key index, okay, in square brackets because it's a variable. That gives us the number, right? We did those key values up here, gives us a number that relates to whatever this is. And from there, we do some math. So let diff equal something. What is it? Well, it's letter value minus key value, okay? Remembering that now we have numbers for both these, okay? It's just numbers and numbers and numbers. So everything is math. Lots of console logs if you get through this and things aren't quite making sense. But this is going to give us a diff. The problem is, besides the fact that I mistyped that, okay, the problem is that this could be negative, okay? If it is, then we need to add 26 to it. That's the number of letters so that we go all the way back to all the way to the end and then come back, okay? So right here, that's why we're using a let. We go if math, spelling it right, math.sign equals, math.sign diff equals -1, a number, not a string. I've made that mistake too, okay? Then we set diff plus equals 26, okay? So if we've done the math and it's negative, then we shift it to the far end of the alphabet, okay? Hopefully that's making sense because we are almost done this. I feel like it's a lot, but stay with me for a second. We're almost done, okay? So now we return, okay? What are we returning? Well, we're checking if values.length equals 2. So now we're going back to this values and we're seeing if we had two things, because if we had two things, the first one is a space, right? So let's go and return that. Let's make sure that that all lines up where we go an array and we go values.at 0. That's the first one. And then whatever that diff is plus UTF-8 or UTF start, UTF start. Okay, so we are resetting it back to its original thing, right? Back to its actual UTF name or number, okay? That's what we're doing here. We're actually going to grab this because I want to do this a second time down here, just like that. This does not need to be an array. It could. It doesn't hurt anything because flatMap will absolutely do that part for us. But if we pass back a number, it'll just toss it in there. If we toss an array, it will flatten that into the thing. Okay, so at the end of it, this is going to be an array of UTF codes. Okay, and all we really need to do is take this and translate it back to a string. Well, we can do that down here using string.fromCharCodes, if I could type it right, codes, tossing it in, and hopefully, I messed this up. We do not pass an array to it. We pass in the individual numbers, okay? And it still doesn't work. What did I miss? Scanning really fast. Values at this one? Yeah, okay. fromCharCode. It's weird because you can pass in as many codes as you want and it will join them up to make a string. But string.fromCharCode is singular. That'll probably bug me later, but here we are, okay? And yeah, it works. It was a huge amount to get here. So let's back it up, okay? In the previous video, we went through how to get this this string, okay? That string we used inside as a key, which is something that we can change. So long as the message has been encoded with the string, we can also decode it with that same string. So in theory, we'd have an encoding mechanism that would use a key, which we could then share into decoder and everything would work, okay? We set up some variables, okay? So we subtracted, as an example, A being 65, subtract 64, that gives us 1, which is the position that we want for the alphabet. A equals 1, okay? Which is kind of what they said up here, A equals 1, okay? From there, we also encoded our string. So we turned it into numbers, and we did that using this handy singular tool, right? TextEncoder. It only has a couple methods on it, the most useful being encode. You pass in a string and it returns an array of UTF numbers, whatever those numbers are for each individual character that is in that string. We mapped over that to, again, reduce it down to something between 1 and 26, okay? Something from 1 to 26, not between, including, right? From there, we had to split. We split our characters and we used a flatMap where we basically pulled it apart. When we split, we also included the space because this doesn't care about spaces. It only wants to line up one-to-one with the actual characters, which is kind of weird, right? That's very weird. So we included the space in front of whatever character that was, right? Which means that when we come down here, we might have an array with either one item or two items, right? It might just be a character based on today's tests, right? If we do something else, we really should check all of this code. But based on today's tests, it will either be one character or two characters, right? If it's two characters, then the first of those characters is a space. But in order to make sure, could I have just done whatever the space is? I think it's 32. Yeah, I could have. But just in case, right? Making sure, because maybe my tests for something else, right? Maybe it tests for numbers or something like that. So I never want to mess with that, which means that I want to play it safe, okay? But before we got there, we did some work. So we figured out what our key index was, and that's based on these key values, which are based on the key, right? So which key are we using? And using that to get our new value. Then if it was negative, we added 26 so that it wrapped around, right? And used all that to put it back together. At which point we did the final step of taking those character codes and turning them back into a string, right? So much, like just a lot of stuff happening here, but it seems to get the job done, okay? I tried it a few different ways. The code, every single time the code started to blow up, and I suspect that it might be that way no matter how I did this. So here we are. This is today's solution. Again, not every solution, just one good solution. Hopefully you liked it too. If you didn't, if you found a better way, right, or even a different way, share that in the comments. Otherwise, today, this has been the second part of Hidden Key, and I will see you tomorrow.